Hi, welcome to my channel pibyme Maths. This is WST02. Here we are solving May June 2023 Statistics 2 paper. Let's look at question number 1. In a large population, 40% of adults use online banking. A random sample of 50 adults is taken. The random variable x represents the number of adults in the sample that use online banking. Find this. So you can write x follows binomial distribution of n. N is 50. The probability of success is 0.4 here. So when they say P of x is equal to 26, the formula is NC, N is 50, NCX, P to the power x, Q is if P probability of success is 0.4, probability of failure is 1 minus P, which is 0.6. 0.6 power 50 minus 26. This is the formula. P of x is equal to x is NCX P power x Q power n minus x. So let's get this value. So it's 50 C 26, okay, times 0.4 to the power 26 times 0.6 to the power 24. 0.02593 you can round it to 3 significant figure. Okay, now you can find this value using the table also. You can write this as P of x is less than or equal to 26 minus P of x is less than or equal to 25. You can get the table values of these two and subtract. You will get the same answer. That's another way of doing it. Let's look at part B. Double P of x is greater than or equal to 26, which is same as 1 minus P of x is less than 26 or less than or equal to 25. So let's get the table value, or you can use a calculator also. Go to distribution, binomial CD. We don't need the list, we need a particular value. So number 2. The x value is 25 now, and the value of n is 50. Probability of success is 0.4. So you will get this value 1 minus 0.9426 ... and then you can just cancel it. 1 minus the answer 0.05734 ... 0.0573. That's all. Now triple I now. Find the smallest value of k for which P of x is less than or equal to k is greater than 0.4. Okay, we have to open the table and look for n is 50, P is 0.4. You will get several values of x, several values given there in 4 decimal place, right? You have to find all the values that are bigger than 0.4, and then you need to get the corresponding x values also, and then you need to find the least value of x. So I have put the table values here. The corresponding values of x are 12, 13, 14, 15, 16, 17, 18, 19, 20. So the values that satisfy this condition more than 0.4. This is less than 0.4, less than 0.4, more than 0.4, more than 0.4. The smallest value is 19. So you can write n is equal to 19. Just write this. Not n, it's k. That's all. Part B now. A random sample of 600 adults is taken. Now n is 600. Find using a normal approximation a probability that no more than of 222 of those 600 adults use online banking. So here the probability of success is 0.4, same like what's given here, right? Okay. So to apply the normal approximation, you need to find mu and sigma. So for B, this is B, BI, mu is NP, which is 600 times 0.4. Sigma is square root of NPQ, which is square root of 600 times 0.4 times Q. Q is 1 minus 0.4, 1 minus P. So 600 times 0.4 is 240 times 0.6 is 144. Square root of 144 is 12. So you can write used x here, so I'm going to use y follows normal distribution of mu comma sigma square. Now they want us to calculate y is no more than 222, so y is less than or equal to this. So now we need to apply continuity correction. Now this is same as y is less than 222.5, and then standardize the normal distribution. Z is less than 222.5 minus mu over sigma, and then using the method we learned in S1, you need to get the value of this using the normal distribution table. First let's calculate this. 222.5 minus 240 over 12. Sigma is just 12. That's minus 1.46. So P of Z is less than minus 1.46 is same as 1 minus P of Z is less than positive 1.46. So let's look at the table value for positive 1.46. 1.46 is here, the value is 9279. So it's going to be 1 minus 0.9279. So the final answer is 0.0721. That's the final answer. Now for double I, explain why a normal approximation is suitable. Because n is large and p is close to 0.5. You need to write this. That's all, just one more question. Let's move on to question number 2. State one characteristic of a population that would make a census a practical alternative to sampling. If the population is small, you don't have to take a sample. You can, let's say you want to take a survey in a school of 1,000 students. So you would rather take a sample of 100 students or something and take the survey, right? But let's say that particular institute or something has only 100 students. You don't need to take the sample. You can just talk to every one of them. That's called census. If you take data from the population, all members of the population, that's a census. So if the population is small, you don't need sampling. You can just use census. That's basically you're going to talk to every people in that population, every member of the population. So if the population is small, the census is alternative to sampling. Part B now. A leisure center has 2,500 members. It has a sample of 300 members for their opinion on the fees it charges for using the center. For the sample, identify a suitable sampling frame. Even though they mentioned for the sample, the sampling frame actually a list of a roll number or names or something they might have for all these 2,500 members, right? That list is a sampling frame. A list or a register, you can write register or database of all members. You have to mention all, otherwise you will lose mark. Not 300 members, all members. That's the database. So that's the sampling frame. What is a sampling unit? So individual member, in this case a member is a sampling unit. That's all. Part C now. The leisure center has the following piece of information. A is the list of different types of membership that can be paid for by members. Okay. B is the mean of membership fees paid by all 2,500 members. C is the number in the sample of 300 members who are satisfied with the fees they pay. Okay. You need to remember the definition. If you look at the definition for statistics, this statistics is a quantity calculated based on the a sample and it shouldn't contain any unknown parameter, population parameter. This is a population parameter by all the members. This also all the members. This is sample. So C is the statistic. As it does not contain, as it is based only on values taken from sample. And no population parameter. So there are certain definitions given in the textbook. You have to memorize all those definitions and the disadvantage, advantages of sample, census, all those things. Okay, anyway, question number 3 now. It's a continuous random variable. It has a PD of this. Show that C is this. We know if we integrate the function from 2 to 5, 1 over 48 x square minus 8x plus C. In discrete random variable, sigma p of x is 1. Continuous random variable, the area below the curve will be equal to 1. You can keep 1 over 48 outside, x cube over 3 minus 8x square over 2, which is 4x square plus cx, 2 to 5 is equal to 1. So bring the 48 to the other side and sub in the upper limit. 5 cube, it is 125 over 3 minus 5 square is 25 times 400 plus 5c minus, sub in the lower limit now, you'll get 2 cube over 3 minus 2 square is 4 4s are 16 plus 2c is 1. Make c as a subject. 5c minus 2c, 3c is equal to, I'm going to calculate this now carefully, 125 over 3 minus 100 minus 8 over 3 plus 16. Okay, we got minus 45, but we need to first move the 48 here, right? So this becomes 48 actually. So we have minus 45 plus 3c is 48. So 3c is 80, 93, c is equal to 31. We got the answer already. Part B, find p of 2 to 3. Just integrate the function from 2 to 3. So 1 over 48 integral 2 to 3, the f of x, x square minus 8x plus 3, x square minus 8x plus c, c is 31 dx, which is x cube over 3 minus 8x square over 2, which is 4x square plus 31x 2 to 3, which is 1 over 48. Sub in the upper limit, you'll get 3 cube over 3 over 3 minus 4 3 square plus 31 times 3, that's upper limit, minus lower limit 2 cube over 3 minus 4 times 2 square plus 31 times 2. So let's simplify this. 3 cube over 3 is 9 minus 4 9s are 36 plus 31 times 3, that's 66, minus 2 cube over 3 is 8 over 3 minus 4 4s are 16 plus 2 times 31 is 62, which is minus 146 over 3 times 1 over 48. So 1 over 48 times 66 minus 146 over 3. 13 over 36 is the answer. Just a 2-mark question. Part C now. State whether the lower quartile of x is less than 3, equal to 3 or greater than 3. Okay. We have calculated the answer this previous part. We got 13 over 36, right? The value of it is 0.3 something. 0.3 something. Okay. And the function, if you look at the function, the limit is 2 to 3. Alright? 2 to 5, sorry. 2 to 5. 3 is in between actually. So when we find the probability from 2 to 3, the lower limit to some point in between the limits, we got this actually. For example, let's say when you find the probability of 2 to 3, you are getting 0.25. So definitely this value is lower quartile, because from 2, if you take the function, that's a quadratic function, all the way to 3, from 2 to 3, this area is 0.25, right? But we got the area 0.3 actually. From 2 to 3, this area is 0.3. But for lower quartile, from 2 to lower quartile, the area should be 0.25. So definitely it should be smaller than 3. If it's bigger than 3, if the lower quartile is bigger than 3, the area will be more than 0.3, right? That doesn't make sense. So you need to write it clearly here. 13 over 36 is bigger than 0.25, therefore Q1 is less than 3. Hope you understand this part. Now the next part, part D. CAIE does the following to work out the mode. She has taken the function, differentiated, equated to 0, x is equal to 4, and she has written mode is x is equal to 4. CAIE's answer for the mode is incorrect. Explain why the method does not give the correct value. Okay, the mode is when you take a probability density function, the mode is the point where the function takes the maximum value, the corresponding value of x. But here if you look at the PDF function, it's a positive quadratic. So when you find the turning point, you are not finding the mode actually. 4 is the value, 4 is the point where the function takes the minimum value, not the maximum value. So you need to write x is equal to 4 is the x coordinate of the minimum point. Minimum point as the quadratic is positive. As the quadratic is positive. So that's the answer for D. So what is the actual mode? Okay, the function is defined from 2 to 5. So you need to check which value is maximum. So you need to find f of 2 and f of 5 and check which one is maximum. In the function is 1 over 48 times x square minus 8x plus c. 8x plus c. So when you find f of 2, it's 1 over 48 times x square minus 8x plus 31. That's 0.395 dot dot dot. When you find f of 5 now, 5 square 8 times 5, get 0.3333. So you need to write f of 2 is bigger than f of 5, therefore mode is equal to x is equal to 2. That's all. Question number 4. Given n is large, state a condition for which binomial distribution can be reasonably approximated by Pearson. It has to be n is large and p is small. Just write p is small, just a 1 mark question. Part B, a 4 mark question. Manufacturer produces candles. Those candles that pass a quality inspection are suitable for sale. It is known that 2% of the candle produced by manufacturer are not suitable for sale. A random sample of 125 candles are taken. Use a suitable approximation to find the probability. Okay, probability that no more than 6 of them are not suitable for sale. This is very important because here 2% are not suitable, so we can take that as a probability of success, 0.02. So x follows binomial distribution of 125 comma this. They want us to use a suitable approximation. P is small, n is large, so we can write lambda is np is 125 times 0.02. 125 times 0.02. That's 2.5. So we can write y follows Pearson distribution of 2.5 no more than 6. So they want us to find y is less than or equal to 6. Just take the table value for lambda is equal to 2.5 and x is 6. So lambda is 2.5 is this column, x is 6, 9858. The answer is 0.9858. That's all. You don't have to round it, actually leave it as it is. Okay, next part now. The manufacturer also produces candle holders. Charlie believes that 5% of the candle holders produced by the factory have minor defects. Okay, so Charlie believes that 5% have minor defects. The manufacturer claims it's less than 5, not 5%. To test the manufacturer's claim, a random sample of 30 candle holders taken. N is 30. The probability of success is 0.055%. Carry out a test. 30 candle holders taken and none of them are found to have minor defects. That's 0 is the observed value. Carry out a test of the manufacturer's claim using 5% significant level. So H0 is P is equal to 0.05. That's Charlie's claim. H1, they believe that it's less than 0.05. Okay, we don't have to find the critical value. We are going to use method 1 because the observed value is 0. First write candle, so I'm going to use C. C follows binomial distribution of 30 comma P. Now first we write that, assume that H0 is true. So C follows binomial distribution of 30 comma 0.05. And we need to find the value C is equal to 0. We can apply the formula here. NC0 P power 0, this is P, probability of success. So probability of failure is 1 minus P, that's 0.95. 0.95 to the power 30 minus 0. So 0 is 1, anything above 0 is also 1. Just find 0.95 to the power 30. 24163, 0.2146 dot 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 0.215 is the answer. Oh, sorry, we are not finding the answer. We are just checking we are doing the hypothesis testing. This is bigger than the significant level, 5% significant level. So if the calculated value, you just need to remember this. If the calculated value is less than the significant level or the observed value lies in CR, we reject H0, otherwise we do not reject H0. In this case, the calculated value is bigger than the significant level, so we do not reject H0, we reject this. So we need to write here this H0, we accepted this, not this. So manufacturer's claims, there is insufficient evidence to support manufacturer's claim. You need to write that, otherwise you will lose amount. Next part, give a reason why this is not an appropriate test. Okay, you see, the manufacturer, right, he says there are less than 0.05 defective item, right? And when you calculated the probability of the items with 0 defective, when you calculated, you reject this claim as per the hypothesis testing. That's what happening here, right? But this is what manufacturer also saying, right? He is saying that it's less than 0.05. So it can be 0 also. So by right, we should have accepted manufacturer's claim, but as per the hypothesis testing, since the calculated value is bigger than the significant level, bigger than the threshold, we rejected his claim, right? So that's why this is not an appropriate test. So how do we write the answer? The H0, the null hypothesis, is not rejected though P of D is equal to 0 is same as manufacturer's claim. Hence, this is not an appropriate test. Let's look at part D now. Ashley suggests changing the sample size to 50 now. N is equal to 50. The probability is 0.05. Comment on whether or not this change would make the test appropriate. So when you put 50 and find it, you're going to get 30C0. You will still get 0.95 power 50 if you sub in into this formula, right? Because 50Z0, probability of success power 0, 95 power 50. So when you calculate this, 0.95 to the power 50, you are still getting a number bigger than this. 0.0769 etc. is greater than the significant level. Still not possible to reject H0. So you need to write, therefore Ashley's change would not make the test appropriate. Would not make the test appropriate. Because it's not affecting anything. Still we are not rejecting H0. That's all.